All right, number 27. In an analogy between traffic flow and electric current, what is Q? Well, Q is the charges are the thing traveling through the circuit. So here you're talking about the cars traveling through traffic. I is the current itself, so maybe that would be the speed of the traffic or the average flow of the traffic would be what you compare to the current. Number 32. How long does it take for 10 coulombs to pass through an area when the current is 5 amps? So now we're talking about current equals charge over time. We're given current, we're given charge, find time. I think you can calculate that. 33. A hairdryer uses 9 amps, 9.1 amps. How long does it take for that much charge to go through? Again, we're given current, we're given charge, find time for part A. Part B, how many electrons? Well, then they're saying they're not giving you a time frame, so they just want you to take this charge and turn it into electrons. So you turn that into electrons. So you need to multiply by the 6.2 times 10 to the 18th number. Sorry, again, I'm drawing with the mouse at the computer, not with the active board. 6.2 times 10 to the 18th. And what that'll do is I'll tell you the number of electrons. Number 34. What factors affect resistance? You've got the length of the wire, the area, the cross-sectional area, the width of the wire, the temperature of the wire, and what the material itself is. 35. Each of the wires shown is made of copper, assuming each piece of wire is the same temperature, which has the greatest resistance. Looking at the three pieces there, the two wide ones, A and D, would not be the greatest resistance. So the greatest resistance would be C. It is both narrow and long, so C would have the greatest resistance. The least resistance would be between options A and D, D being wide and long. Long is not good for resistance, but wide and short in number A is going to be your least resistance. Looking at number 40, a nichrome wire, that's your toaster wire in the old, where there's lots of tiny little wires in the toaster, has a resistance of 15 ohms, is connected in the terminal of a 3-volt flashlight battery. How much current is in the wire? So here you're going to use Ohm's law, and that is I equals V over R. So R of 15, V of 3, 3 divided by 15 is going to give you your current for number 40. Number 42. Calculate the current of each resistor shown. And you're going to do the same deal. You've got resistance of 5, 2, or 20, depending on A, B, or C, and you got your 9 volts. So you're just going to divide there for 42. 47. What quantity is measured in kilowatt hours? Kilowatt hours is the quantity, it's what electrical energy, it's what you're paying for. What is measured in kilowatts? That is power. Okay, a little difference there. The one thing to pay attention to, there was, unfortunately, in the review, I did not spot a question that had you calculate how much you pay for electricity. So make sure you pay attention to that in the old notes or in the homeworks on how we pay for electricity. That's highly likely to be on the test. But there was no good review problem that had a cost of energy in anywhere, and I was really frustrated about that. And last question, number 51. A 6-watt light bulb and a 75-watt light bulb operate at 120 volts. Which one has a greater current? And for that one, P, power, equals I times V. And it looks like you're going to do the calculation twice. 60 watts and 120 volts, find current. And then 75 watts and 120 volts, find current. I would also want to be able to manipulate the other power equations with P equals V squared over R and P equals I squared times R, in case you're given resistance to worry about too, kind of like the bell work today where we talked about resistance, which light bulb had more resistance. Alright, I try to keep the review short, and I try to keep the test short, but there was a lot of different things to talk about in the test, so there's a lot of information to cover. Alright, good luck.